Welcome. Created my first meme. This is our new kitty, Lucy, in the picture. Okay, so what I'd like to do is to give you a demo today in RStudio. I will assume at this point that you've been to the content section, that you've looked at the week 2 information, you've read this blurb here, and you've downloaded the places where this says download. Now, the file that you really need for what I'm about to do is this RMD file, chapter 3 code. So be sure to download that. To download it, just click on the down arrow and then select download. So now we're going to move over to RStudio. It appears that I have a lot of stuff over here on here. So I'm going to quit all of this. Save all these selected. All right, now I'm going to come down here and turn on, click on RStudio. I put it down in my dock here. If not, you want to run it somehow. You can see I've got some things in here, but I want to start off by running a new project. So this basically, I'm going to just put it in the existing directory of week 2 and just say create the project. So here comes the new project. It's got several windows. If you don't see all this stuff, let me show you where you can get it. I'm going to click out all of these. I won't save that one. Click that one and click that one. Okay, so some of you might come here and all you have is this environment window, this files, plots, packages. Today we're going to do a lot of work in plots. And then this is the console. This is the console. So I'm going to open the file. And I'm going to go to the downloads because I just downloaded that file, and there it is. So I'm going to double click on that. So here's the file that I've created for you so that you wouldn't have to type in. And it's fairly, long because there's a lot of code. We can't possibly do justice to everything that's in this package. This is an R markdown file, RMD file. And so if you want to run code, what happens is you highlight this. And I would, as you go through this document, highlight every piece of code and then come up here to run that code. Now, I normally will just do a control return on my Mac or a control enter. So I would come to here at the end of this, and you can't see it, but I'm typing and holding down the control key and then hitting enter. And then down here, you'll see that it's installing tidyverse. The next thing I want to do is come to the end of this, and I can run it from here. I can run the select line, just as you see here, and says, okay. We made tidyverse available, and now we're loading all the files because we're going to load it. One of the things that I mentioned that you're going to want to do, it's at the top of the homework, is to do ggplot2, and notice it has quote, and then control return, and that'll load ggplot2. So that's important because if you load that package, then all the data sets that come with that package. Now, if we want to know what's in that package, what it's all about, we can come down here, and this is the help window. So every time you ask for help with the question mark, it'll give you all this information. Notice that Hadley Wickham, one of our textbook authors, is also the author of this ggplot package. And here are a couple of resources down here if you want to see more. What ggplot does, the first thing you want to do is to add this layer every single time. Add ggplot and then select the data source. That's your first layer. And then at the end of each line, if there's another layer, okay, so we come down here and just type this, control. It says, okay, it looks like we wanted to draw a plot, but you didn't give me another layer to tell me anything about that plot. So if you come up here, you have both the setup for a plot, and then you're going to add this point. GM point is the command that we use for a scatter plot. So, and then you start with your mappings. And the mapping is, you give the aesthetics. That's what this means. And here you're defining the variable X and the variable Y. Now, when you see stuff in blue with these pound signs in front of them, that means this is a comment. And so what I would do if I were you is I was going through this, is to attach some comments next to these code segments. So for example, down here, if you do control return, it gives you MPG. Okay, so if you go to the global environment and just look at the ggplot package, that'll put that in there. And then if that's loaded, then you can type in MPG and you can see all the different variables in MPG. So there you go. Now, if you just type MPG like this, what this just says is, what is that data set? And so when you do this, it's going to give you not the entire data set, but you can see that it gives you 10 rows of that data set. Now up here, it tells you the dimensions. So this is 234 rows by 11 columns. So that means you have 234 different cars here, and you have 11 variables: the manufacturer, the model, the display. Here they are over here. It tells you whether they're a character string, like a qualitative variable. If they're numerical, that means they're decimal numbers. Integers means just integers, no decimal numbers. Cylinders, 4, 5, and 6, and so on. Now, a command that we like to use a lot is, because to save space down here in our console, the head will just list the top 6 data points. So it saves you a little bit of time in the console. It saves you a little bit of space in the console. All right, so there's the head, and you can see it's pretty much the same thing as MPG. If you want the dimensions, just trying to figure out some information about this, you can see the dimension is 24 rows and 11 columns. What I like to do is to try to get a sense of what each one of these variables means. So if you want to recall a table that gives you all of the values of an individual variable in a data set, you can do something like line 26 there. And what we want is a table somehow related to this variable manufacturer. So let's do control return or control enter. And all of this was together. And so when I said, execute one line in here, it executed it all. And so this is nice because you can see that when you do table of manufacturers, there appears to be several different manufacturers in this data set: Audi, Chevy, Dodge, Ford, the normal ones you would expect. There's even more models because there's multiple models of Chevy, multiple models of Fords, and so on. Now, usually a table is not helpful for numerical data. So it's a 1.6 liter engine, or it's a 7 liter engine. So the bigger engines are over here and the smaller engines are here. But you can see there are 5 vehicles that had a 1.6 liter engine. All right, for the year, turns out here that we have 117 cars from 1999 and 117 cars from 2008. How many cylinders does the car have? Well, again, this is some measure of the size of the engine. There are 4-cylinder. These are all gas engines: 4, 5, 6, and 8. What kind of transmissions do they have? Automatic or manual? The different kinds of automatic and manual transmissions. What is the drivetrain? Is it a 4-wheel drive, a front-wheel drive, or a rear-wheel drive? Rear-wheel drive. Some of your problems, I ask you to find, which category is the most popular. And here you'd see 106 is higher than 103 and 25. So okay, the city mileage, this is a numerical variable, so probably table. Same thing for highway mileage. Not so. Now, FL is the fuel type. Ours regular. You can see regular gas is the most popular gas used. This is premium. This is this e-gas, diesel, I guess, and not sure what that one is, but one of them runs on that. And then the class. If you were going to rent a car and you went to Avis or Hertz and you rented a car, these are the classifications of the different kinds of cars that you would see. Okay, now this information here on class is not so interesting, but I'll run it just so you can see what it is. It basically tells you what type of variable you're working with. So for example, class was a character. Down here you can see class as a character. just to kind of emphasize this notion of layering, in R, if you want to assign one thing to a variable, this is how you do it. You use the less sign and then a dash. And that says we want to assign to K this thing ggplot data equals MPG. So basically we want to create we want to call K the first line in our graphing command, our visualization command. Now this does nothing very interesting, as you can see. It just says we're going to assign this K. But now if we take K, which is all of this, and then add the bar graph command, and we want the X value, what we can do here is generate a bar graph, which is nice because it tells you all the different manufacturers down here, and you can see the most popular. It looks like Dodge is the most popular, although this graph is very, very crowded. You can look at the next one. Here's one by model, and that's even worse. Very unclear. So this is not a very good. So the geom bar and ggplot, those are part of the ggplot2 package, but there are some commands in R that do quick and dirty graphs like histograms. In histograms, we graph numerical data. So this is going to be a histogram, which is a bar graph for numerical data. See, it looks quite different. And then another popular graph that we have for numerical data, like the displacement, the size of the engine, 1.2 liter, is a box plot. And if we were going to publish this graph, we'd want to, add labels and a title and so on. The years, not so interesting. We know we have 117 vehicles from each of those years. The most popular cylinders, not too many 5 cylinders, but 4. The smaller engines are more popular than the larger engines. The transmissions, you can see, manuals over here. All these are automatic. I4 is the most popular. The drivetrains, 4-wheel drives, front-wheel drives, rear-wheel drives. All right, for a histogram for the city mileage, how much mileage does your car get? My pickup is about 20, I think. Well, there's where my pickup would be, about 20 miles to the gallon in the city. And here are the more fuel-efficient cars. And here are the gas guzzlers. For highway mileage, quick and dirty graph. All right, back to the ggplot package. Now we're going to plot the FL, which is the fuel type. And you can see regular by far is the most popular fuel type. And then the class. And notice on the class one here, instead of having X, this creates a vertical bar graph. But if I say Y is class, then it converts the vertical bar graph into a horizontal bar graph. So you'll have a couple of homework exercises where the graphs will be horizontal. The other thing is that I might as well stop here. We've created a lot of graphs. These are plots. And you can only see one plot at a time, but all of the other plots that you created in this session, you can see by going with the back arrow. So you can see them all. You just can't see them all at one time. All right, so this one is a multiple bar graph. So notice that I ran these 3 together. It gave me the table between class and cylinders. Here's the class, and here's the number of cylinders, and here's all the data in table format. That's this command. And then this one here does the corresponding graph. Now, Dodge here, and I'm maybe just put it right up here for you. Dodge is what creates the multiple bar graph. Yeah, so I'll put a comment up here, use position equals. So then you get the multiple bar graphs. If you don't include Dodge, then you're going to get your basic stacked bar graph. So if you want the multiple bar graph, the default is the stacked bar graph, but if you want the multiple bar graph, you have to use the Dodge. And so inside the ggplot, when you do this mapping here, you declare the X and you declare the Y. Now this is a scatter plot, so you need to define both the X and the Y, whereas these bar graphs up here, there's only one variable that you plot. For scatter plots, you need both the X and the Y. Now, when you say color by class, when you come over here, the different types of class are the compacts, the subcompacts, the SUVs, and on and on and on. what it's going to do is it's going to color the data points that are of a certain class. And this is very useful as a visualization because, you know, what you see is a lot of the pink ones, the pink dots here. I'm pointing to this color. Those are all toward the bottom. And so you'll notice a couple of things, that the SUVs are all down here. And the two-seaters. So these are you know, fancy two-seater cars. They don't get that great if they're really, really small cars and they've got these huge number of cylinders, so they have all this power, but you know, they might be small cars, so they still get. And then the SUVs are down here under 20, and the blue ones, the pickups. So the purple ones way up here, the subcompacts, you can see they have a higher highway MPG. I threw a couple of other ones in here just so notice that this graph here, you know, we're basically just switching the X and the Y. And you can choose X to be anything and Y to be anything. Just make sure that they're numerical variables. You don't want to have a numerical scale down here and then use a categorical variable. It's not going to make any sense or little sense. And so I think on the rest of these, what I did is I just chose the color. You know, based on the different qualitative variables. And so you can see here, reds and blues tend to be down toward the lower left. And that means lower gas mileage and lower, both in the city and the highway. So these blue and red ones, they are the four-wheel drives and the regular ones. The front wheel drives tend to get better gas mileage. All right, so what does this function alpha do? All right, now we're back to a scatter plot, GM point, and X is display, Y is highway, and then you see alpha is class. So what it does here, when you use alpha, it's going to use a gradient color. And so you have from the lightest, the two-seaters, down to the darkest SUV. So you can see where the light ones are and the dark ones there. So you can use gradient colors as well. Shape, we have lots of shapes, but I think it only displays about 7. And so let's see what happens here. Yeah, it gives us this error message down here that says, you know, hey, we can only display 6 of these. And so it displays these and doesn't give. So basically you're not seeing the SUV plotted here. So that's a limitation. And it gets too busy if you want more than 6 anyway. So it's probably a good idea not to include more than 6. Yeah, so these two go together. And in this one, notice your intent in both of them is to have the color blue. And I wanted to indicate to you that this is important. So for this one, it is blue. Good. And for this one, it completely ignores it because the color blue in mapping needs to be outside the aesthetics for X and Y. It's just another mapping. Now, if you wanted to call color a class, then you can put it right inside here. But to give it an attribute like a color, that has to go outside. So it completely ignores this color equals blue if it's inside the XY mapping aesthetic. Okay, so we're going to start to add some bells and whistles. All right, and when we run down this one, notice that this is ggtitle, and notice it puts a title on there. If you want to horizontally adjust that title, you can do it this way and look at the title here, shifts it over. Now, this is not very interesting because in the scatter plot, we have one of the variables as being the DRV. You know, it is a numerical variable category, right? So you see it does a category. It's not how we typically see a scatter plot. All right, and in this one, we set up the plot. It's a scatter plot. We're going to plot displacement and highway, color by class, and then we're going to create the size by the fuel, and we're going to create the shape by the drive, and of course the drive is F, R, and 4, I believe. So there's just 3 of them. So we should see 3 shapes, and fuel fuel kind, I think there's 5, so we should see 5 different shapes. And yeah, so you can put a lot of these different aesthetics, all referring to geometry point. And this might get too much of an overkill here, but you can see that you've got circles. That's a small circle. That's what is that, pink or fuchsia, and it's circular. So you have medium size fuel type. You've got the SUV, and you've got, it's a circle, so it's a 4-wheel drive. So you can put them all together. All right, over here, it says color equals city less than 20. So if the city mileage is less than 20 mpg, it's going to color it one color. And if it's greater than 20, it's going to create a different color. So again, using colors, the red ones would be city less than 20 is false. So that means the city mileage is larger than 20, not so many. All right, then we're going to get into some facets. And this is where you might want to see lots of different graphs together. And so there's facet grid and there's facet wrap are the two. So we know that class over here is compact. I think there's about 6 or 7 different class identifiers, but we want to put them in 2 rows. We're going to do display on the x-axis and highway on the y-axis. And so we should see 2 rows of graphs. Let's take a look. All right, so we have a 2-seater, a compact. These are the 7 different. And so we wanted them in 2 rows. And so it gave us those 7 graphs in 2 rows. If you wanted 7 rows, because we have 7 variables, you could change that 2 to a 7, run again. And this is going to give you 1, 2, 3, 4. That's not a very good. So if you want 1 row, that's not very good either. It kind of squeezes them all together. So maybe 3 is the best one. 1, 2, 3. And it automatically puts as many graphs as it can. All right, Scatterplot equating those 2, but looking at a 3rd variable, and that's class. Well, what if we look at number of rows 5 for manufacturer? All right, there they are. You can see all the different manufacturers. There's 15 here, and we're able to get them all into 3 columns, 5 rows. All right, now when you don't specify the number of rows, but instead you want to map all the levels of class with all the levels of cylinder 4, 5, 6, 4, 5, 6, 8, I believe in class. There's like 7 of them. So let's see what this gives us. This gives us a scatter plot between, but there you can see you've got all 4 number of cylinders compared to all 7. And you can see the scatter plots on each of them. Not too many 5s. And you can see where the compacts are. Compacts are more over here in the 4-cylinder. Now, if you do facet grid, because you want to bring in that variable, you can see it. There are 3 different levels of the drivetrain. And then here you see all the different displacements, liters. This is a numerical scale, and then you've got 3 different categories. Numerical, numerical, numerical on the X, numerical on the Y, and then categories. Now notice when we have the tilde and then period, it gives us the train, and it gives us the 3 values of the DRV variable in rows. If you flip-flop that, then it's going to orient these graphs in a different way. Now we've got the 4 graphs going in columns. Decide how many rows you want to add to that facet. Here we have the 1, 2, 3 different labels, and we do them in 3 rows. If we did in 4 rows, it wouldn't make a whole lot of sense because we have just 3 levels of that variable. So let's see what happens. All right, didn't need 4. If you had 2, then things would get a little different. Okay, so it looks like we're going back to the basic scatter plot, and then we're going to introduce this smooth. Okay, so this is like going through all of the points of a so this one is just going to give you a curve. It's not going to give you the scatter plot. All right, so it's a smooth curve, like a curve of best fit, if you will. So if we wanted to separate that smooth curve and do a line type, like a solid line or a dotted line or a dashed line. And by drivetrain, there are 3 levels of this variable. And there you see the 4-wheel drive are down here, the front wheel drives are here, and the rear wheel drives are here. So, and notice the curves don't go all the way from left to right because there are no data values for the entire 0 to 7 range. Back to our original graph, and then let's see what this is going to do. We want to involve color, so we're going to bring in the drivetrain. It's going to be a color, so there should be 3 different color lines because we're doing smooth. Let's take a look, and there they are. Instead of using the line type, we're going to be using color to look at those segments. This one, you'll notice that the legend is false, so there is no legend, but this one, the legend is true. So you can turn on and off the legend. Notice now the legend is over here. So in this one, you have both the data points or the scatter plot and the smooth curve together. And notice the code in this one here is slightly different than the code right above, but it essentially does the same exact graph. All right, so now this one, we're going to do a smooth curve, and we're going to have scatter plot, but the color is going to be the class. And for class, we've got about, I think, 7 different classes, so we should see 7 different colors here. And there you see all the colors. So it's only the scatter plot that has the color. The smooth curve does not. All right, so now the scatter plot has the color, and the smooth curve has, oh, it looks like we want only, we're going to filter. Now, this might be the first time you see the filter, but you can see up here, we select data to be MPG. And then when we do the smooth curve, we only want to do the graph of the MPG data, but we only want to look at only that one class field, subcompact. And the SE is the shading. So if you want to get rid of the shading to that curve of best fit, then you say SE is false. So let's take a look. Since we're filtering down to the subcompact only, we should only see the curve where the subcompact data appears. All right, so subcompacts went out to here, and then we didn't have any subcompacts with these higher engines, more liters. And notice that there is no shading on this one. When we run this one, we're going to see shading, but it looks like everything else is the same. So you see the shading on the line of best fit there. So this one, very similar, but instead of filtering by subcompact, we're going to be filtering by compact. The new curve segment is going to be in a slightly different place. So there it is. And notice we didn't want the shading of the graph on that. Okay, so for this next one, because we've got the data defined here, need that, and because of the mappings and the aesthetics appear in the ggplot, these aesthetics apply to everything that comes down here. So we're going to have this color aesthetic in Scatterplot as well as in the curve, the smooth curve, and we're not going to do the shading. And there you have it. Colors in both the smooth curves, no shading, and colors in the, and it doesn't look like we see D. Is D in there? I guess D is up here. So didn't look like C was plotted anywhere. I do see a red point there, but there's not many of those C fuel types in there. Not sure what that is. Okay, so the next part of this, we're going to be looking at a new data set called diamonds. And so just to get a sense of what that is, let's take a look. Diamonds, prices of over 50,000 round cut diamonds. You've got the price, the number of carats. A lot of wedding rings are about 1 carat, but you can see they go up quite a bit. Then these diamonds are cut. And what is the quality of the cut? Fair, good, very good, premium, and ideal is an ordinal level variable. And you get all of these. X, Y, and Z are numbers, length in millimeters, width in millimeters, depth in millimeters of the diamond. How clear it is from worst to best clarity, color from best to worst. All right, D through J. All right, I'm going to come up here and I'm going to do diamonds, and There it is. So here are the different variables for listed in the diamonds. All right. So if we want to do the head command here, you'll see the top 6. And if you want to do some tables, not so interesting, because the variables are all numerical, real numbers. And so when we're counting up the number of real numbers that exist, there's always a lot of them. So probably the only tables that are meaningful to us are the ones right up at the top here. So, and maybe not even carat. So here's the number of carats. That's not very interesting. So I would say that because cut, color, and clarity are all ordinal level variables, qualitative, it makes sense to come up with frequency tables for those. And so you can see the cut, that if you create a table from the diamonds data set, $, the variable cut, then it gives you the frequencies of all of those. So you can see that the ideal cut is the most popular. For colors, you've got color D up to color J, and it looks like the color G is the most popular of those color types. For clarity, we have the worst clarity to the best clarity, and the most popular clarity is about looks like SI1. The rest of these are numerical, and so it might make sense to see what the graphs look like. All right, so it looks like for this one, we're going to graph a bar plot of the cut. There it is. And remember, if we just do Y, then run the same thing, you have the horizontal bar graph. When you run this, this code here was in the book, textbook, and later on we'll look at what tribbles are in a little bit more detail. But right now you can see it looks like they're creating a table, and we're going to do a bar graph. So in this first one, we're going to let Y be the frequency. And when we do that, you can see frequency is over here on the Y axis. All right, so this one down here, notice that the Y, instead of just being the frequency, we're going to let it be the proportion. And this is how we ask it to be the proportion on that vertical scale. This would be the equivalent to a relative frequency bar graph as opposed to a bar graph. So when you do that, you see this, and notice we have the proportions here. And 0.2 would be like 20%, 40%, and so on. All right, so here's some alternative. Notice for this one, it's going to recall the data set diamonds, and it wants the stat summary. And so cut versus depth. Let's see what happens here. All right, not so interesting. It looks like we're just going to plot the min, the max, and the median in a stat summary. So, and it looks like it was a plot. So I'm not sure how interesting this would be, but let's look at the very good. Looks like it goes up to 65 and down to about 57. 57 and 65. Okay, so this particular graph, not so interesting, but if we throw in there, a group equals 1 and run again, we get something interesting. This one here, not so interesting, group equals 1. And if the field is based on clarity, this is what we have. Okay, so here's some slight variations on this curve. So I'm going to put this label in here, some not so good graphs, and let's see if we can see why. Well, when we run this one, not very interesting because it just has all the cuts and everything goes up to 100%. Not very interesting at all. This one here, again, every single column of graph is exactly the same. So there's some redundancy here in what it is that they're doing. It's not a very, very useful graph. This one here, we're using cut as both the x-axis and the color indicator. And here, again, not so interesting because cut is both the legend here and the x-axis variable there. Yeah, and so here are some better ones. You can see here from this one that, you know, most of the diamonds are ideal, then premium, and then very cut. And then you've got these classify, this other variable there. And just remember that another feature, and basically say position is equal to dodge, and then run this. And then we have the multiple bar graph. Oops. All right. For the next graph, same thing, but notice that for this one, they added this alpha factor, which is the kind of the gradient. Position identity, the same thing. Okay. And for the next graph, you can see the fill is not applicable. So there's no fill. In the next one, position dodge gives us the multiple bar graph. Here, MPG data, city versus highway, just a basic no color scatter plot here. This would make sense because as the city mileage increases, so does the highway mileage. So here's a box plot. Notice that X, the horizontal scale, is class. That's a categorical variable. So we're going to have a bunch of categories going along the horizontal scale, and then the vertical scale is going to be all the highway mileage. This next one, if we flip the coordinates, those box plots, instead of being oriented vertically, they're going to be oriented horizontally. Okay, in this next one, I think they wanted to give you a kind of introduction to the fact that you can construct maps. And so they ask you to install this NZ package. And so we'll do that. If you haven't installed this, then you'll want to install it if it promotes you to. Here's another orientation of same map. Yeah, so here's something that you can do. I just wanted to illustrate again the assignment. So I'm assigning this ggplot to bar, all of this. And then when I come down here and I run that, it gives me the graph. And so then I can take that same graph and then add a layer to it to get, if you flip them, and then if you take that graph above, that one again, and you apply a polar coordinates to it, that's what it looks like. So here is kind of some generic text to use a ggplot. You got to select your data. You got a geometric function. You got the mappings with AS with the mappings. You have stat. You might want to select a stat, and you've got position. So you can look at the different positions, the different stats. So as I mentioned, we're not going to get to everything, but this is text code here, but generally this is the format that a command in R is going to look like when you use ggplot. So in this one here, notice we're not doing anything other than just to assigning this plot to T. And then when we run T, we get this. And then you will be asked to create some labels, labs, and you want to separate each one of the labels with a comma. So label your x-axis, label your y-axis, give it a title, give it a subtitle, give it a caption. Notice all these labels are in quotes, and each one is separated by a comma. So when we run this, look at the bald graph over here, and if we add lots of labels, you can see that the labels appear, x-axis label, y-axis label, there's a caption down at the bottom, and then a title and subtitle up at the top. All right, so just playing around here, we've got diamonds. We're creating a new variable diamonds. If in the diamonds, I want to assign to the value, the variable W, just the product of X and Y and Z. When I run this, so if you think of the diamonds as being rectangles, then length times width times depth would be a box that surrounds the diamond. And so I just created this new W, and then we can plot with W there. So if the rectangular box that contains the diamond increases, then probably the carrot's getting bigger. So let's see if we have a scatter plot that has an increasing trend to it. There it is. I'm not sure what that is, but got a big box, and it's a 2-carat diamond. So, and then this looks like maybe an outlier, and these looks like a lot of zeros. So I'm suspect about those two data values. And so what I'm going to do is I'm going to make sure that diamonds is non-zero, greater than 0.01. I'm also making sure that here's about 800. So I want to get rid of that point and just look at the data set in here and then get rid of all these. So I'm setting a filter. I believe in filters a lot because in many of the data science problems that you solve, you're not going to be interested in the entire data set. You're going to be interested in a subset of it. So you always want to filter the data down to the data of interest. All right, and this is what it looks like if we do the filter. You can see that's a very, very, very strong relationship there. And then for this next one, looks like I'm going to add some color. And there it is. So you can see the cuts of the different diamonds in the picture as well. All right, this next one looks like we're comparing carat with, which is the size of the diamond, along with the price. As carats get bigger, the price gets bigger. All right, so we have this huge scatter plot. All right, and in this next one, we're going to throw in the color. And you can see there's lots of diamonds, lots and lots and lots of diamonds that are 1, 1.5, 2, 3. And then finally, I'm throwing in a lot of other filters here. And these are the ones where we want the price of the diamond to be less than $3,000. So there's your scatter plot. Okay, so there's a huge variety. And I guess if one of the things that you can do with all of these lines of code is, let's say that there's a problem from the homework and it says that you want to filter out the data so it only includes these data values. Well, what you can do is come into this document and do a search and then just type on something like the command filter. And then you can just go down to the next. Is that one you want? Or there's another instance, or there's another instance, or another instance. So you can search for the keywords and then come down and then just run that code and then play around with the filter to see what would I need to do to narrow my data set down to a smaller amount. Okay, so during the week, if you have questions about any of the code, doing some of these things, generating some of these graphs, if you want a hint, I'll go ahead and make a request. And, I can do a video like this to focus in on one particular function or another. So, all right, have a great week, and I'll see you back here next week.